Examples from 10.4. This is more details on slope. The title in Hawkes's point slope form, and we will do a little bit of that at the end, but that is not the emphasis. The emphasis is on the meaning of the slope and how we can work with it. So first example, find the equation of a line that has slope 4 and goes through the point 2, -2. We did something like this in the last section, but let's review. So first I want to just quickly sketch it in order to check my answers. So I'm just going to do a rough sketch and say, okay, I'm going through 2, -2, so 1, 2, -2. I'm purposefully not using the graph paper because you can sketch this just on any paper that you're working with. And then a slope of 4. So slope of 4 is positive, so I'd be going over 1, up 4, over 1, up 4. So this is roughly what the line looks like. So I know my y-intercept here is going to be negative y-intercept, and they already gave me the slope, so I know that. Nothing interesting there. Okay, let's find the equation. Find the slope. Done. We have the slope is 4. So then I want to find the y-intercept. They gave me a point, so let's plug it in. So we have my basic y equals mx plus b. I'm plugging in 4 for the slope, and so then I have y equals 4x plus b, and then I'm taking my 2, -2 and plugging that in for x and y. So x is 2 and y is -2. That's how I can set up my equation to solve for the y-intercept. Put in my slope, put in my point, and now let's solve. So 4 times 2 is 8. So I have 8 plus b equals -2. Subtract 8 from both sides, so I get -10 equals b. That is my y-intercept. Negative, check, check, that matches. And so I have the equation of the line. Y equals 4x minus 10. I hope that's just becoming a little bit fun for you as we are becoming more familiar with it. Number 2. Find the equation of the line with slope 0 and passing through 3, -4. Still review, but it just might feel funny, so I thought I would do one of these. So try to stay ahead of me. You could pause the video and try it yourself. Sketch it. So 3, -4, 1, 2, 3, down 4. Here's the point. Slope of 0 means no change in the y. So it's a horizontal line. The y-intercept then I can see is negative. And I can actually tell what it is. That's going a little further, that it's going to be -4. But let's go through our same process and see that you don't have to do something special. We plug in our point, which is 3, -4, so y is -4. And our slope was 0, and the x was 3, which you know is not going to matter, but I can put that, plus b. Same setup, 0 times 3 is 0, plus b equals -4. So 0 plus anything is that thing, b, which is -4. So negative, yes, check, that's what we were expecting. My equation then, y equals the slope, which is 0 times x, minus 4. Let me write it out. 0x plus 4. or y equals 4. I did not check on Hawks if they will allow the first one. They should, but I have not confirmed it. The traditional way would be just to simplify it to y equals 4. Okay, let's do some new material. Find the equation of the line that passes through 1, 1 and is parallel to this line. Parallel is going the same direction, so roughly here are two parallel lines. What about the equation tells us the direction? It's not the y-intercept. That tells us where we cross something. The slope tells us how much we go over and how much we go up, how much we go over, how much we go up. So parallel lines here have to have identical slopes. That is a key idea. Parallel, same slope. So to work this question, I identify what is the slope in my equation. Slope is the coefficient on the x, so that is negative 3/4. If I want a parallel line, I need to have the same slope. So they've told me my slope and a point. Then it's back to how we did it before. So I plug my point in. I have y is 1. Slope is negative 3/4. X is 1. And plus b. Solving for b. Negative 3/4 times 1 is negative 3/4. Add 3/4 to both sides. So I'm going to write my 1 as 4/4. And then add 3/4, I get 7/4 is my b. So practice not being intimidated by fractions if they throw it at you. Use a calculator and just keep track of them the same way. So the y-intercept is 7/4. My equation, my answer would be y equals negative 3/4 x, because it's the same slope, plus 7/4. That line is parallel to our original line. Same slope, and it also goes through the point 1, 1. I want to do part B. I want to change the question. What if we change this to perpendicular? Perpendicular is at right angles. So if I have one line here, the perpendicular needs to come at right angles. So it would cross it with a square corners. All four of these are right angles. So let's play with this just a little bit to see how would we figure out a perpendicular line. So I'm going to erase our work from before. And you can try to visualize a perpendicular line. So I'm going to just grab a line with slope 2. So I'm going, here we go. I'm going over 1, up 2, over 1, up 2. How would I want to go to be perpendicular? So some ideas might be saying make the slope negative. So if we do a negative slope, then let's do a different color. We would be going, say, just from this point, over 1, down 2, over 1, down 2. So this would be the negative slope. Is that perpendicular? No, this is not right angles. This one's smaller, this one is larger. We want those to be equal. So this line isn't quite it. It needs to rotate this direction. in order to be at right angles. So let's say if I start at this point, how do I stay at right angles? I want right angles would be right here. What's happening to our slope? If you figure it out before I tell you, it will stick more. We're going over 2, down 1, or down 1 over 2, down 1 over 2. So here the blue line slope was 2 over 1. Our perpendicular line that worked, the slope equals negative 1 over 2. We had to adjust 2 things about it. We did want to go the opposite direction, so we did want negative. But we also needed to take the reciprocal. So we need to switch the roles of x and y. You could think of that. So we're flipping the rise and run, and as well as changing the sign. And then we get our perpendicular line. So what does that look in this exercise? By the way, this concept isn't the most important of the section. It's a smaller one, but you will have a couple exercises with it, and it's kind of fun when you see it. So, okay, find the equation of the line that passes through 1, 1 and is perpendicular. So I take my slope of negative 3/4, and I need to do 2 changes. I change the sign so it'll be positive, and I flip it. So I flip it to be 4 over 3, take the reciprocal, and I change the sign from negative to positive. If it had been positive, then I would switch it to negative. So opposite sign, opposite rise and run. That's my new slope. That's my perpendicular slope, I should say. I still need to find the equation. So this part's just a little review, a little routine, slightly tedious. So 1 is y, and slope is 4/3. X was 1, and plus b. 1 equals 4/3 plus b. Get my common denominator, so I'll replace 1 with 3 over 3. Subtract 4/3 from both sides, so I get negative 1/3 equals b. That's my y-intercept. My slope was here. You have to be a little more careful now that we have different slopes. And my answer would be y equals 4/3 x minus 1/3. This equation would be perpendicular to this first equation. If you're feeling any confusion as you're working this and you want a graphic, you could go to Desmos.com and graph the 2 equations to make sure your answer looks correct, that it's actually looking perpendicular or parallel, whichever one they're asking for. Or search for Desmos graphing calculator. Don't use this crutch too much, but it can help visualize situations. All right. I should say don't use it as a crutch, but use it as an understanding tool. Last example. We just are given the graph of an equation, and it says find the equation of the line. But they do throw in point slope form. We were writing all of the others in y-intercept form. So let me show you what this idea this is relying on. Slope equals change in y over change in x. So let's say I don't like fractions. Anyone here not like fractions? How do I get rid of fractions? I multiply both sides by the denominator. So x2 minus x1 is in the denominator. If I multiply that, we'll cancel, but I have to do it to both sides. That gives me my point slope form. So point slope form, usually they might flip it around the equals, but it doesn't really matter. So y2 minus y. Well, actually, okay, then they usually just drop the subscript on the first one. So you have y minus y1 equals x minus x1. So what they say is let that second point be any point that I have on the line. It needs to relate to the first point in this way. That's the kind of relationship we're describing. Saying any other point x, y on the line has to have this slope compared to my known point x1, y1. So that was awkward. All right, the eraser. What does this look like now? Let's go back to our exercise. So I need to find a point. Find a point on here, and any point, let's choose this point. So this one has coordinates 1, 2, 3, 4, 5, and 1, 2, 3. 5, 3. That will be my point. So I'll put in the 5 for x and the 3 for y. The other x and y are just any variable x and y. And then all I need is the slope. So the slope, I am reading off of here, going, rise is, first going left to right, rise is 2, run is 3. So my slope, rise is 2, run is 3, it is positive. Here is my answer. I didn't check. They might require you to write it in the opposite order around the equals. So y minus 3 equals 2/3 times x minus 5. This is usually what they are looking for. You can experiment if you're curious about other forms, if they'll allow this. It is correct, but they may want it in the traditional format. So if you want to memorize the particular point slope form, it's the change in y equals the slope times the change in x. You don't have to. I don't think that will be on the exam, but if that's familiar to you, but think about it as change in y and change in x so that you can relate it back to your slope that it came from. Slope is change in y over change in x. All right, those are the examples from this section. Have a great day.